If your Excel sum looks wrong with big numbers, you're not imagining it. You might add a column and get a result that's off by a few units, off by hundreds, or it suddenly flips into scientific notation. In most cases, Excel isn't bad at math. It's following strict limits on how numbers are stored. The key idea is simple. Excel uses floating point arithmetic with about 15 digits of precision. Past that, Excel starts rounding, and rounding changes totals. And if you're working with very large values, you can also hit overflow in certain functions or formats. In this video, you'll learn how to diagnose the exact failure mode, then pick the right fix. Formatting, rounding strategy, scaling, or switching to exact text-based methods. You'll also learn a few quick tests that tell you whether you're dealing with display issues or real calculation errors. By the end, you'll be able to trust your totals again, even with huge datasets. Next step. Let's separate two problems that look identical. First is a display problem. Excel might show 1.23e plus 18, or round the visible decimals, but the stored value could still be fine within Excel's precision. Second is a true precision problem, where the stored value is already rounded, so sum is adding slightly different numbers than you think. A fast check is to increase shown decimals, then compare the cell's value in the formula bar. Another check is to subtract what you expect from what you got, and see if the difference is tiny and random, which often signals floating point rounding. Also watch for imported numbers. If a value has more than 15 digits, Excel may silently change the last digits on import. That's common with IDs, account numbers, and long timestamps. Once you know whether the issue is display, storage, or import, the fix becomes straightforward. Don't jump to rounding everything yet. First, confirm what kind of error you actually have. Next step. Here's the core technical limit. Explained simply. Excel stores numbers as IEEE 754 double precision floating point. In practice, that means you get about 15 significant digits that are reliable. If your number has 16 digits before the decimal, Excel can't store every digit exactly, so it rounds the tail. For example, a 19-digit invoice number is not a number in Excel. It's really an identifier, and Excel will mangle it if you treat it as numeric. Another classic case is summing many values with cents. Even if each value looks like it has two decimals, the stored binary value might be 0.1 style, and small errors can accumulate. This is why you sometimes see totals like 99.999997. The fix isn't to fight Excel's storage model. The fix is to design your sheet so the math happens within safe precision, or you switch to exact representations when you need exact digits. Next step. Now let's talk about overflow, because people use that word in two different ways. One meaning is when a calculation exceeds what Excel can represent, and you get errors like num in certain functions, or results that don't behave as expected. Another meaning is when your sum is technically valid, but the precision is so limited that the last digits become meaningless. With sum, the second case is far more common. You'll see it when you're adding huge values together, like totals in the trillions, while also expecting exact cents. Excel can represent a trillion, and it can represent cents, but it can't always represent both at the same time with perfect accuracy, because you're running out of significant digits. A practical rule: if your totals have more than 15 significant digits, the least significant digits will be rounded. So the overflow fix is usually about scaling, rounding strategy, or changing how you store the numbers, not about replacing sum itself. Next step. A surprisingly common cause of wrong totals is hidden non-numeric data. If some values are stored as text, sum ignores them. If you have numbers with commas, spaces, currency symbols, or non-breaking spaces from copy-paste, Excel may treat them as text, even though they look numeric. Another trap is numbers that are numbers, but include trailing characters, like an apostrophe or a unit. The fastest way to test is to use ice text on a few suspicious cells, or multiply a value by 1 in a helper column to force coercion. You can also use value to convert cleanly, but it will fail if there are hidden characters. For large number workflows, this matters, because imports from CSVs and systems often mix true numbers and text numbers in the same column. Before you chase precision ghosts, confirm that all add-ins are actually numeric, consistently in the same format. Otherwise, your sum may be missing rows entirely. Next step. Let's handle the cleanest fix first, rounding at the right stage. If you're summing currency, you often want to round each line item to cents, then sum the rounded values. That matches how invoices and ledgers work. If you only round the final total, small binary fractions can accumulate and push the final number a cent off. A practical pattern is a helper column that uses round to the required decimals, then sum that helper column. For example, round to 2 decimals for currency or to 0 decimals for whole units. If you need banker's rounding or specific accounting rules, choose the rounding function that matches your policy. The trade-off is that rounding early can slightly change totals compared to pure math, but it usually matches real-world expectations. The key is consistency. Decide where rounding happens, document it, and make your sum operate on those standardized values. That alone fixes most precision error complaints. Next step. When numbers get extremely large, the best fix is often scaling. Scaling means you store and calculate in a smaller unit, then display in the original unit. For money, that might mean storing values in cents as whole integers instead of dollars with decimals. For big measurements, it might mean storing in thousands, millions, or using a base unit like grams instead of tons. This keeps the significant digits where you need them. If your total is in the trillions and you still need exact cents, you're trying to keep too many meaningful digits in one value. Store cents as integers and you regain exactness, because integers up to 15 digits are safe. Then you can format the result to show dollars by dividing by 100 for display. The trade-off is that you must be disciplined about conversions, so you don't double scale or forget to scale back. But for large number precision, scaling is one of the most reliable long-term solutions. Next step. If you're dealing with 16-digit plus identifiers, the fix is not rounding. The fix is to stop treating them as numbers. Things like credit card tokens, shipment IDs, and long account numbers should be stored as text, so Excel doesn't change the last digits. That means setting the column to text before importing, or using an import method that preserves text. If the data is already damaged, you often can't recover the original digits from Excel alone, because they were never stored. For calculations, you usually don't need to sum identifiers anyway, but you might be doing lookups, matching, or deduping, and precision loss breaks those tasks. The safe approach is store IDs as text, keep monetary values as numbers, and never mix the two concepts in one column. If you must do math on extremely large integers beyond 15 digits, Excel is not an exact big integer calculator. In that case, you'll need text-based methods or a different tool for the computation step. Next step. Here are a few diagnostic formulas that quickly reveal what's happening. Use len to check how many digits a value has when converted to text, and compare that to what you expect. Use exact to compare two supposedly identical IDs because it won't coerce types the way equal sometimes appears to. Use sum and sum product as a cross-check when you suspect hidden text or coercion issues, because sum product can force numeric conversion in some cases. If you suspect tiny floating errors, subtract the rounded version from the original and see if you get a small non-zero remainder. Another useful test is to add a very small value like 0.01 to a huge number and see if the result changes. If it doesn't, you've hit the point where that small unit can't be represented at that magnitude. These tests don't fix the problem by themselves, but they tell you which solution to apply: rounding, scaling, or text preservation. Next step. Let's talk about a setting that sounds tempting. Set precision as displayed. It forces Excel to store numbers rounded to what you see. This can appear to fix precision issues instantly because it eliminates hidden decimals, but it's a workbook-level change, and it permanently alters stored values. That means it can break models, audits, and any downstream calculations that relied on full precision. In other words, it's not a casual fix. If you're building a simple sheet for reporting and you fully understand the consequences, it can be acceptable. But in most professional workflows, a safer approach is explicit rounding in helper columns, or scaling to integers. Another tempting fix is converting everything to text and using concatenation tricks, but then you lose numeric behavior and performance. The best practice is to keep numbers numeric, keep identifiers as text, and control precision with deliberate formulas. Use global precision settings only when you're sure the workbook is meant to be that way from the start. Next step, to wrap it up, fixing some issues with large numbers is about choosing the right strategy for the job. If the issue is display, adjust formatting and verify the stored value. If sum is skipping values, clean up text versus number problems from imports. If you're off by tiny amounts, round line items before summing, especially for currency. If you're mixing huge magnitudes with small units, scale your data so the meaningful digits fit inside Excel's 15-digit precision. And if you're handling long identifiers, store them as text from the beginning, so Excel doesn't rewrite them. Once you adopt these habits, your totals become stable and predictable. If you want, I can also provide a simple checklist you can reuse for any workbook that handles big financial totals or large data sets. If this was helpful, subscribe for more practical Excel troubleshooting. And in the comments, tell me which problem you hit more often. A. Rounding errors, or B. 16-digit IDs getting changed. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.